Okay, in today's video we will be looking at finding the distance between 2 points, and then later looking at finding the midpoint between 2 points. Okay, we're going to start off by looking at finding the distance between points. And our first example is a very specific case when we're looking at horizontal lines. Okay, so when we are dealing with a horizontal line here, you will notice that the y coordinates are both the same, so the distance is just the difference between the two x coordinates. Okay, every time you get a coordinate, okay, it's always a good idea to label it x1, y1 and x2, y2. So the distance for this question here would be x2 minus x1, the difference between the x coordinates highlighted here. So it would be 7 minus 1, and we would get the answer 6. So that line would have a distance of 6. Okay, as well as horizontal lines, we can also be looking at vertical lines. Okay, and vertical lines work the same. This time we know the x coordinates are the same on a vertical line, so the distance between the 2 points will be the difference in the y coordinates. Okay, so it's y2 minus y1. Again, we've labelled our coordinates x2, y2 and x1, y1, so we know which one's which. Okay, so y2 minus y1 will be our distance. Therefore, it's going to be 8 minus 1, so that line has a distance of 7. Okay, let's look at a question now. So if we were to calculate distance between these points here, okay, well, you will notice from this question that we have the y coordinates the same. Okay, and always a good idea is to sketch out what this would look like. Okay, so if we drew ourselves a set of axes and we put down these coordinates, okay, you would see we actually have a horizontal line, okay, where the y coordinates are the same, both being -3. So to work out our distance for this line here, then we need to work out the difference between the two x coordinates. So it's x2 minus x1, and again, if you look at my question, okay, it will be 16 minus -7. Okay, be careful with your negatives here. Two negatives change that to a positive, so it'll be 16 plus 7, which gives you a distance of 23. Okay, right, let's look at this. So what happens if we are not in the case of horizontal or vertical? Well, we need Pythagoras to give us a hand here. So we'll want to find the distance of this red line here. I'm starting off at this coordinate x1, y1 and ending up at the coordinate x2, y2. Well, what we can do is we can break it into horizontal and vertical parts. The distance between the horizontal part, okay, difference here is the difference between the x values, so it's x2 minus x1. Similarly for the vertical, the difference would be y2 minus y1. Okay, so if we want to work the distance of that line or that line, we would need these values here. Now, using Pythagoras, we know the length of this side squared is these two lengths added together but also squared as well. Okay, so that's why we get that formula there. So the distance here squared is the length of this squared adding onto the length of that squared. To then get our value for d, we get this formula. We get the square root of x2 minus x1 squared plus y2 minus y1 squared, all square rooted. Okay, that is the formula we will use for distance. Okay. Right, let's look at an example. So A is the point -2, 4 and B is the point 3, 1. Calculate the length of the line AB. Well, the first thing you always do is make sure you label your coordinates. So here I'm going to call this my first coordinate, so it's x1, y1. This will be my second coordinate, x2, y2. We're then going to show the appropriate working. So to work out the distance of the line AB, or the length of AB, we're going to write down our distance formula. So we're going to start off with the formula, which we've just seen on the last page. It's x2 minus x1 squared plus y2 minus y1 squared, all square rooted. To follow the best line of working, then we put in our values first. Okay, so we're just substituting in the values here, so that's why it's highly important that we label these so we know where these go. So x2 minus x1, well, that was 3 take away -2, so that's 3 take away -2 in there. We then have y2 minus y1, so that's 1 take away 4, so that's going to be 1 take away 4 there. And we need to remember we're squaring these, adding them together, and then taking the square root. So if we are being careful here, 3 take away -2 gives me +5. 2 negatives make a positive there. So 3 plus 2 is 5. I'm going to square it. 5 squared is 25. 1 take away 4 is -3, but if we square a negative, we will get a positive, so we get +9. Okay, and if we add them together, we get the answer the root of 34. Now, at higher level, we can leave it at root 34, we can leave it as a surd, okay? We might need to sometimes with a question simplify it using our surd skills, however this one cannot be simplified any further than root 34. Okay, so that is an example of how it can be used there. I'm going to quickly show you the second example. We're not going to spend too much time on this one, okay, but it's just to show you you can be asked to deal with fractions here, okay. However, basically we start off with the same thing. We're going to end up starting off with our distance formula. We then substitute in the values of the coordinates that we wrote down, okay, and then you would take it one line at a time by working with your fractions, getting the same denominator so you could subtract and add them together. You can then work out how we would get each part and then square it, add them together, get the same denominators again, and you would get that as your final answer there. Okay, so I don't need to worry too much on that one. However, it's just to show you can be asked to deal with this with fractions. There's an example here if you need to look at it again. Right, well that's it for the distance and using the distance formula. We're now going to look at working out how to find the midpoint. So finding the middle of a line, okay, if we know the coordinates of the two endpoints, then the middle of a line is found by taking the average of the x coordinates and the average of the y coordinates, okay. So basically we get this formula here, okay, so the midpoint of this coordinate and that coordinate there, well, you add your two x coordinates up and then finding the average, so you have to divide it by 2, and then we same thing for the y coordinate. We add the two y coordinates up and divide it by 2, and again you'll see it's very important to label your coordinates x1, y1, x2, y2. Right, so that is the formula for the midpoint. Let's look at an example. So we're going to calculate the midpoint of the points 1, -4 and 7, 8. Okay, first thing we do is we always label these coordinates. So we're going to call this our first one, x1, y1, and we're going to call this second coordinate x2, y2. And then we're going to work out the midpoint. So the midpoint, okay, we have this neat formula here. So the x coordinate will be x1 plus x2 divided by 2. The y coordinate will be y1 plus y2 divided by 2. We're then going to substitute our values into this. Okay, just making sure we remember and deal with the negatives as well. So x1 was 1, x2 was 7, so it'll be 1 plus 7 divided by 2 there. y1 was -4, y2 is 8, so it'll be -4 plus 8 divided by 2 for that part. We can now work this out. Okay, so if we do this carefully, 1 plus 7 is 8, if we divide that by 2 we get 4, -4 plus 8 is 4, divide that by 2, we get the answer 2 there. So our midpoint of that line was 4, 2. Okay, and that is an example of the midpoint there. So the key things of this video is the distance formula, okay, the midpoint formula, and showing the appropriate lines of working, ensuring that you always label your coordinates x1, y1 and x2, y2. Okay, thank you.